For problem number 2, we just need to graph the function y equals negative x cubed. Well, what we should know is that y equals x cubed, even if you had to plot a few points, 0, 0, 1, 1, 2, 2 cubed is 8, negative 2 cubed is negative 8, and how about negative 1? Negative 1 cubed is also negative 1. So if we plotted all those points, we'd have 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. The graph of y equals x cubed would look like that. So therefore, if we put a minus sign in front, we could either think of that as reflecting it about the x-axis, which is really what we have. When we have a negative x cubed, that's the opposite of x cubed. But in reality, it could also be written as y equals negative x cubed. And the good thing is, whether you flip this graph over the x-axis or the y-axis, you're still going to get the same graph. And that's going to look like that. Don't have to be too careful about exactly what points these guys are going through. So just the idea that you have the correct curve. And the one thing I should point out is that there is a flat point. There's what we call a horizontal tangent at the origin. And so I get kind of picky about that. And instead of just drawing it like this, kind of like that, there should be if I do this in a different color, so if you were to draw, when you draw the graph, you kind of draw it like it's going to be coming back up like that, like a parabola, but instead it goes down the other side. You can see the difference between the behavior of this graph over here, which is what we don't want, to this behavior at the origin on the actual graph of y equals negative x cubed. There's a flat spot. Here on this one, there's no flat spot. All right, so let's see if we can set this up. Maybe for problem number 3, we have a little work to do here. A rectangle is inscribed in a circle. The radius of the circle is 17 feet. That's a very inconvenient radius. Nevertheless, it's what we have to work with. So let's go ahead and draw the circle. That's a 17 there. So the radius is 17. Now, a rectangle inscribed means it's inside. So we've done a few of these. Inside the circle, inscribed inside the circle means that the upper right corner, actually each corner of the rectangle is on the circle. Now, the equation of a circle with the center at the origin is x squared plus y squared equals r squared. And that's not a function, so if we want to create a function so that we can represent the area of the rectangle in terms of one variable, we have to define y to be we have to define y to be a function of x. Now, I should also have done this. 17 squared. What's that? 289. So I think that's right. 289. So y squared is 289 minus x squared. And if we take the square root of both sides, we get y equals plus or minus the square root of 289 minus x squared. So how does that pertain to what we're looking at here? Well, the top half of the circle, I think we've done this a few times here, the top half of the circle would be the positive square root of 289 minus x squared, and that's really what we need. The bottom half of the circle then would be the negative square root, by the way, just to make sure we finish that thought. All right, so now when we put the top half together with the bottom half of the circle, we create a full circle, and we can also then discuss the height or the distance between the x-axis and the top right corner of this rectangle in terms of x. And so that distance then would be radical 289 minus x squared. That's a key number, and the other key number is this guy right here, and that's just x. All right, so what So now we've done the legwork. Now let's go ahead and bring this all together. So what x value maximizes the area? Well, in order for us to find a maximum value, we have to define whatever we're trying to maximize in terms of a function of x. Okay, so what I'm going to do here is I'm going to set it up in this video, and then we'll solve it in the next video. So to set it up, we need the area in terms of x. Okay, so what then would be the area of a rectangle? Well, the area of a rectangle is length times width. So we know that area is length times width. Well, what's the length? The length would be equal to, so half of the length is x, therefore the full length would be 2x. Okay, times. Now, we talked about the height I should say, we talked about the distance from the x-axis to the top right corner, which depends on x, would be this guy right here. Therefore, two of those, still the distance is radical 289 minus x squared. So therefore, the width would be two of those guys, two of the radicals. So I'm going to write it just like this, 289 minus x squared. And that's the area. That's the area in terms of x. So we have a 2 times a 2, that gives us 4, times the x times the square root of 289 minus x squared. So that is our area function. And like I said, I'll make a second video showing you how to figure out what the maximum area would be and what x would be required to maximize that area. And maybe while well, actually, I'll do that in the next video.